Today we will be discussing about 4-level laser system. Depending on the number of metastable states, we have seen that there are two types of laser system. 3-level laser system and 4-level laser system. We have discussed about 3-level laser system in the previous lecture. Today we will be discussing about 4-level laser system. Now before going to discuss about 4-level laser system, let me brief about 2-level and 3-level systems. We have seen that it is difficult to achieve population inversion in case of 2-level system, but we can get or we can achieve population inversion in case of 3-level system. As population inversion is not possible in 2-level system, we are not getting any lasing action in case of a 2-level system. So lasing is not possible in 2-level system, whereas we can get lasing action in case of 3-level system. But the difficulty with 3-level system is that the output whatever we are getting, that is not continuous. We are getting a pulsed output. So the output is in the form of pulses. So this is a typical form of output of a 3-level laser system. Here you can see we are getting output from this in this interval, but in this interval the output is 0. Again we are getting output for a small interval and it is becoming 0. That is because the population inversion cannot be maintained in case of 3-level laser system. Now let us see, is it possible to obtain continuous output in case of 4-level laser system? So coming to 4-level laser system, it has 4 energy levels. One is ground state. There are 2 metastable states in case of 4-level laser system. One is metastable state 1, which I have taken as E3. Second one is metastable state 2 and the energy is denoted here as E2. And the fourth energy level is the pump state with energy E4. So these are the 4 energy levels in case of a 4-level laser system. Here these E2 and E3 are metastable states. Here generally what happens, the atoms or electrons or molecules, they used to be in the ground state. So these are the atoms which are in the ground state. When the transition of these atoms takes place due to pumping, they will move to E4, and after that there can be different types of transition. They can move to E3, they can move to E2, there can be transitions from E3 to E2 or from E4 to E1. So different transitions are possible, but all are not radiative. To be very clear that we need a radiative transition to have laser action. So let us see from where we can get that radiative transitions. So whenever this atom is moving to E4 due to pumping, after that it can move down to E3. So when it is coming from E4 to E3, that transition is non-radiative in nature. So whenever the atom is moving from E4 to E3, we are not getting any radiation as output. Though we will be getting some phonons because of some vibration or there may be difference in temperature, but we are not getting any radiations over here. Now one more transition is possible from E2 to E1, and that transition is also non-radiative in nature. But the transition which occurs between E3 and E2, that is radiative in nature. If this atom which is moving from E1 to E4, it comes to E3 and makes a transition from E3 to E2, then there will be radiations coming out as output, and hence this is radiative in nature. And as we know, we need radiative transitions to have laser output. That means we are getting the output whenever the transition is taking place from E3 to E2. So these are the transitions which are playing the important role in lasing output, and hence E3 and E2 are the energy levels which are responsible for the lasing action, and hence this E3 is known as upper lasing level and E2 is known as lower lasing level. Let us understand this in more detail. So this is the figure what we have discussed just now. E3 is the upper lasing level, E2 is the lower lasing level, and we are getting output when the transition takes place from E3 to E2. Before going into the details of the transitions which are taking place in this system, let me discuss about the lifetime of the atoms at different energy level. Lifetime of the atom means the time for which a atom can stay at a particular energy level. Let the lifetime of the atom at energy state E4 is tau 4, and the time for which the atom can stay at energy level E4 is very small. That means tau 4 is very small. Now coming to energy level E3, let the lifetime of the atom at energy state E3 is tau 3. Here the atoms can stay at E3 for much longer time as compared to the energy state E4. That means tau 3 is much greater than tau 4. Now coming to energy state E2, let the lifetime is tau 2. Further, tau 3 is much greater than tau 2. Thus, the atom can stay for a maximum time at E3 because tau 3 is much greater than tau 4 and tau 3 is also much greater than tau 2. So, the atoms which are moving from excited state to this metastable state, they can stay here for a longer time as compared to E4 and E2. And this is the principle behind which the lasing takes place or the lasing occurs in case of 4-level laser system. Let us look into that. Let this atom is moving from E1 to E4 because of the pumping mechanism. Okay. Now when this atom reached at E4, it can stay here up to a maximum time tau 4. Before this time it will come down to lower energy state. It may E3, E2 or E1. Okay. So this has two possibilities, either it can move to E3 or E1. So this atom is moving to E3, and as I have already told, this is non-radiative transition. Okay. Now considering another atom which is moving to E4, that is coming down to E1. As I told, the atoms which are moving from E1 to E4, they are having different possibilities to come down. Either they can come to E3, E2 or directly to E1. Okay. Similarly, some other atoms, if they are moving, they can either move to E3 or they can come down E1. So this is the process which occurs simultaneously. Here I am showing one by one, but that doesn't mean that at a time only one atom is moving. Many atoms, they can move simultaneously to E4, and from E4 they may either move to E3 or E2 or E1. So all these processes, these are occurring simultaneously, right? So this is how after some time what happens, these atoms, they are moving to E4 and many of them are moving to E3, few are coming down to E1 and few coming to E2. But the thing is, the time for which they can stay at E3 is much larger as compared to the time for which they can stay at E4 and E2. That means slowly the atoms are getting accumulated at E3. So after a certain time we will see that many atoms are getting accumulated at E3. Okay. So now if we will compare the energy state E3 and E2, we can see that there are a lot of atoms present at E3 and very few or none of the atoms are present at E2. That means considering E3 and E2, we are getting population inversion. More number of atoms at a higher energy state compared to the number of atoms at lower energy state. And this is what the requirement for lasing action. So we are getting population inversion due to this process. Now after getting this population inversion, let me explain how the lasing or the laser output is coming. So when the atoms are staying at E3, if they are staying for a time more than tau 3, automatically they will make a transition to lower energy state. Let this atom is moving to E2. Okay. And as I have already told, this is radiative in nature. That means when this atom is coming from E3 to E2, some radiation will come in the form of photon. So this is the photon which is radiated because of the transition of the atoms from E3 to E2. Now we are having one photon and one atom over here. So what will happen to this atom and this photon? As I told, the lifetime of the atom at energy state E2 is very less. This atom cannot stay here for a longer time. As soon as it reaches E2, within that time tau 2, it will move down to E1. So it is moving down to E1. Further, this is non-radiative in nature, this transition which is occurring from E2 to E1. Now what this photon will do? This photon will hit some of the atoms which are sitting over here. So when this photon is hitting one atom, that will lead to stimulated emission because this atom is being stimulated by this photon. So when this photon is stimulating or triggering this atom will come down to E2. So when it is coming down to E2, again one more photon will be radiated, right? So now we are having two photons. These two photons, they will trigger two more atoms which are sitting over here. So we will be getting two more photons and these two will come down. So four photon, they will trigger four more atoms and that process will continue, and that will lead to a high intense radiation, that is the output of the laser, right? Now by the time these atoms are coming down from E3 to E2, they will stay here for very less time and they will come back to E1. And during this time, simultaneously these atoms which are coming to E1, they will be pumped to E4, and there also they cannot stay for long time. They will immediately come down to E3. That means we are always getting a large number of atoms at E3 and very less number of atoms at E2. So comparing these two, the inversion population is maintained always, and hence we will be getting a continuous output because we are getting the output because of this transition which is from E3 to E2, and E3 is always largely populated and E2 is very less populated, right? Thus, the population inversion is maintained, because of which we are getting a continuous output in case of a 4-level laser system. So this is what we are interested for, and which was not possible in case of 3-level laser system. Now because of this mechanism we saw we can get continuous output in case of 4-level laser system. Now let me summarize the difference between 3-level laser system and 4-level laser system. In case of 3-level laser system, it is difficult to maintain population inversion, whereas population inversion is maintained in case of 4-level laser system. Further, the output is in the form of pulses in case of 3-level laser system, whereas it is continuous in case of 4-level laser system. This 3-level laser system is less efficient and 4-level laser system is more efficient as compared to 3-level laser system. So these are the basic differences between 3-level laser system and 4-level laser system. Today we will stop here. If you like the content, please press the like button and share the link with your friends. Do subscribe to my channel to get the notification whenever I am uploading a new video. Thank you all.